Hello viewers, welcome again to my channel, Second Matter, the solution to your math problems. We are still on trig equations and this happens to be our last question under trig equations. So question 8, given that cos 2x plus 15 is equal to sine x minus 30, and we are told that x is located in the first quadrant, so we have to find the value of x. So how do we do that? So let me repeat the question. Cos 2x plus 15 is equal to sine x minus 30. So someone can decide to, so because the x is inside the trig ratios, we need to eliminate the trig ratios. So if you want to eliminate cos, it means that we have to take the cos inverse on both sides. But in doing so, it will only eliminate the cos on the left, but the cos inverse cannot eliminate sine. When you do same for sine, that is in a situation whereby someone wants to take the sine inverse on both sides. The sine inverse will cancel out the sine here, but the sine inverse cannot cancel out the sine. So it means that you cannot go by that approach. And from the previous example, we said that angles in the first quadrant, specifically in respect to cos and sine, they have a relation. That is, when I have, let's say, cos of an angle 60, the cos of this 60 should be equal to the sine of the complement of 60. We know that complementary angles are angles that sum up to 90. So the complement of 60 will be 90 degrees minus this 60, and this should give us sine. What is 90 minus 60? That is 30. So it means that cos 60 is equal to sine 30. You can verify from our calculator. Cos 60 is the same as sine 30. Cos 60 is giving me 1 on 2. And obviously, sine 30 will also give me 1 on 2. So if you want them to have the same ratio, that is how we go about it. So we just change one sine to the other, and then the angle there will be the complement of the already given angle. So we're going to use the same idea to solve this. Now, in our previous example, we converted everything in terms of sine. This time we are going to rewrite everything in terms of cos. So how do we do that? So on the left we have cos, so there's nothing we can do. We have to maintain the left hand side. So we have cos 2x plus 15. Now we also have to change this sign to cos. How do we do that? So to change the sign to cos, the sign here will change to cos, but the angle here should be the complement of this angle. And what is the complement of x minus 30? Meaning that I have to subtract this angle here from 90 degrees. So that is what we have done. So we can simplify. You see that we have cos on the left, cos on the right. But let's simplify the right hand side. Let's simplify the right hand side. So we have cos 2x plus 15 equal to cos, so we can expand the bracket. So we have 90 minus x, and then minus 1 multiplying minus 30. That should give us plus 30. So we have cos 2x plus 15 is equal to cos 90 plus 30. That should give us 120 minus x. Now, we have cos on the left, cos on the right, so we can easily take the cos inverse on both sides. Take the cos inverse on both sides. So taking the cos inverse of cos 2x plus 15, the cos inverse and the cos will cancel out, leaving 2x plus 15. And this should be equal to taking the cos inverse of cos 120 minus x. So the cos and the cos inverse will cancel out, leaving 120 minus x. So we can group like terms. So I'm grouping all x on the left. So 2x plus x is equal to 120 minus 15. So 2x plus x, that should give us 3x. And then 120 minus 15, 105. We are almost done. We are looking for x, so we divide both sides by 3. So the 3 will cancel out, leaving 105 divided by 3, 35 degrees. So the value of x measures 35 degrees. This brings us to the end of trig ratios. I hope you enjoyed the lesson. So I'm still appealing to you to share the YouTube link to your colleagues, as well as all social media handles. Thanks for watching.